Okay. I'm going to let you guys do the first part because these are all in a reasonably nice form to be able to classify them. So when it says the word classify, all you have to do is write the word that describes what the graph is. So circle, ellipse, hyperbola, parabola. Those are your only options. So that's all you have to do. So I'm gonna leave that top part for you to do. The bottom part says classify each conic section and write its equation in standard form. And for conics, the standard form you can think of as completing the square. That's essentially what you have to do. So this part right here, before the square has been completed, this is called general conic form. And it's general conic form because you can't really tell what conic it is. I mean, you can, but at a glance, right away, it's hard to kind of tell because they all look the same. Right, Jake?
Yes.
Make sure you text that to whoever you're texting so that they know that they look the same. Okay. So, so we have that, and then completing the square is what gets it into standard form. So when we look at the problems, what is a clue that you have something that's a parabola?
Only one thing is square.
Okay, so for a parabola, I'm just going to write down a cheat sheet for myself. A parabola, only x squared or y squared, not both. Okay. And when we do parabolas, do we want the x's and the y's to all be on the same side when we're completing the square? No, we're going to move them, we're going to switch them over, okay? So on the parabolas, we're going to leave the squared term on the left because that's what helps us get it into that standard form for a conic. And then we're going to put all the other stuff on the right, including the other variable that's not part of the squared variable. Okay. So then the other three, the ellipses, the hyperbolas, the circles, those all have x squareds and y squareds on the same side. Well, and they should be on the same side, but in the equation it would have x squareds and y squareds. So what is our clue automatically that what we're looking at is a hyperbola? Yeah, a squared term is negative. It doesn't matter if it's x or y, you just have one of them as negative. And the trick to remember here is that whichever squared term is negative, that term should go second. So negative term goes second. Because hyperbolas are something minus something. So when we know it's negative, that's what the minus part is. Okay, so that narrows it down a little bit. Now we have to determine what's different between an ellipse and a circle. So how do you differentiate between an ellipse and a circle? They're going to have an x squared and a y squared. They're not going to have a minus. Yeah?
The x and y could have the same value before them.
Okay, and that would be which one?
It would just be 1.
But which would that be, a circle or an ellipse?
That would be a circle.
A circle. Okay, so a circle, the coefficient of squared terms are the same. So it could be that you don't see a coefficient, which really means the coefficient is 1. Could be you just see x squared and you just see y squared. Or it could mean you see 9x squared, 9y squared. Or 16x squared, 16y squared. So if you see the same number, that's when it's a circle. So then what's an ellipse? The coefficients are different, and it's a plus. Okay. So coefficients are different, but still positive. So basically, those are the tricks. That's what I look for when I am classifying. So if you look at number 9, they're not all. I can see an ellipse right now. I can see a hyperbola. I can see another hyperbola.
Three out of them are not correct.
Well, maybe I was making your life easier. Actually, what it is, anytime it says CUDA, it's a worksheet generator, and it means I didn't look closely enough at it before I printed it. That's what that means. Okay, so what's number 9? Parabola. What's number 10? Parabola. Can you guys tell which possible directions number 9 opens? It might end up being down, it could end up being up. I'm not sure how the negative would end up working out in the end. But yeah, up or down. What about number 10? Left or right for sure. Okay. What's number 12? A circle. What's number 13? Hyperbola. Can you guys tell which way the hyperbola goes for number 13?
It's like the normal market. The one thing
Left and right? Yeah, perfect. Okay. What about 15? It's got a plus in between them. It's got a 9 and a 1. I've heard ellipse and hyperbola. Okay, so what are we committing to? What are we saying? We're saying hyperbola. Why? Yeah, there's a negative right there. So that's a hyperbola. And should we leave the negative x squared as the first thing? No, it would have to be written second. So which way would this hyperbola open? Up and down, right? Because the y would come first. Okay. Let's go ahead. Let's maybe do number 15 together. So I'm going to put the y first. Since there's not another y to go with the y squared, what does that tell us about the center? What does it tell us? That coordinate of the center would be 0. Yeah. Okay. So with the y squared, I'm not going to complete the square because there's nothing to complete. What do I have to do with the x's so I can complete the square? I'm going to take out the negative 9, and that leaves me with x squared plus 8x. Okay. What number would complete the square? 16. So 8 divided by 2 is 4. 4 squared is 16. We didn't really add 16 though. What did we really put over here? Is it negative 144? Okay, so if we did negative 144 on the left side, we have to do negative 144 on the right side. Is this 9? What goes in my parentheses squared? X plus 4. Okay. And should it equal 9? No, what should it equal? 1. So divide by 9, divide by 9. So y squared over 9 minus x plus 4 squared. You can put it over 1 if you want, but you don't have to. Now, you didn't have to do this part, but could somebody tell me what the center is for this one? Negative 4, 0. Be careful of that. That's the tricky part. It's always the first answer, too. It's always like 0, negative 4. And I'm like, okay. I believe the answer key for this is already online. I'm pretty sure. So you do not have to do all of these. I just want you to practice enough so that you feel comfortable that you can complete the square. Okay, I'm going to give you guys about 10 minutes of working on this, and then we're going to do the application problem. Yay! Okay.